This skill training video has been produced by SEMCA in collaboration with PSSC and CNK. This video is aligned with the job role Supervisor Streetlight Installation and Maintenance, QP code PSS/Q2101, NOS code PSS/N2101. We are now going to learn the step-by-step procedure for planning, monitoring, installation, and maintenance of street light. As we know, the main purpose of street lighting is to enable road users to see properly and easily the carriageway and the immediate surroundings in darkness. So for installation and maintenance of street lights, we need planning and monitoring. Before we go into the details, we will learn about planning, monitoring, installation, and maintenance. 1. Planning. Planning is a process of thinking about the activities required to achieve the desired goal. It is the first and foremost activity to achieve the desired results. It involves the creation and maintenance of a plan, such as psychological aspects that require conceptual skills. 2. Monitoring. Monitoring is the regular observation and recording of activities taking place in a project or program. It is a process of routinely gathering information on all aspects of the project. Reporting enables the gathered information to be used in making decisions for improving project performance. 3. Installation. Streetlight installation is a combination of electrical equipment installed from a common electrical supply to fulfill a particular purpose. A supervisor has to take complete responsibility for the installation of streetlights. 4. Maintenance. Maintenance is a routine action taken on equipment to prevent its breakdown. Maintenance, including tests, measurements, adjustments, parts, replacement, and cleaning, are performed specifically to prevent faults from occurring. Benefits of planning for streetlight installation and maintenance. Energy savings. Here we can analyze that planned streetlight is energy efficient or not. Here we have more options for fixture selection and photometric design. Here we can compare significant cost saving option, that is lease or own. Advanced control options, that is automatic on, off, and protective device, that is MCD, SPD. Here we can plan as per maintenance point of view, that is greater flexibility with installation and removal of fixture. Before installation of new streetlights, following things we have to ensure: streetlight location approval from competent authority. We should have proper design and detail for streetlight, that is height of pole, distance between pole, and material of pole, etc. Here we are measuring distance between street lights, which is coming around 24 meter, and height of pole is 7 meter. Design is also based on the use of road. As per Bureau of Energy Efficiency, road classified in 4 types. A1 road, important traffic in which average lux level should be 30. A2 road, main city road, average lux level should be 15. B1 road, secondary road, considerable traffic, shopping street, average lux level should be 8. B2 road, secondary road with light traffic lux level should be 4. This is a Group B road, as we have measured road width is 7 meter. As per Bureau of Energy Efficiency, here streetlight pole height should be 7 to 9 meter. Here we have fixed 7 meter height street light pole in which we have fixed 90 watt LED light fixture. Administrative and financial approval. Also, we should have cost saving analysis like annual saving on initial investment in using high energy efficient street light fixture. For professional services, prepare a request for quotation RFQ in which following things will be included, like selection of fixture, public process and installation, construction management. Develop contract. We will learn steps for planning street light installation. First step, inventory for installation. What to include: pole numbers, wattage, mast arm type, decorative, standalone lights, etc. A detailed inventory will form the basis of ongoing utility contracts and/or management. Second step, lighting design. Safety. On topmost priority, this parameter is catered for pedestrian and driver safety, creating a sufficient lighting level so that drivers are able to recognize any pedestrians and/or object near the roadway. Security. To ensure by providing a setting that will reduce some forms of criminal activity through the use and placement of lighting equipment. Environmental responsibility. Consideration to following should be given. 1. Energy consumption. 2. Lighting levels. To determine the correct level of output of light required as per client recommendations, which generally have following criteria: A. Road classification, B. Pedestrian conflict activity, C. Calculation of lighting. Lamp type: full cutoff, semi-cutoff and non-cutoff with the use of one of 4 different luminaires that can provide varied lighting patterns. Third step: installation process. Whether we have to change all existing lighting or to change existing in phase manner. Whether we have to change the faulty light with the same spare or to change with new light. Maintenance of street light, in which we will see the wire cable connected properly. Light operation, that is switching on and off. Insulation resistance test. Here we will check the wire laid for street light have proper insulation resistance. Before taking insulation resistance, we are ensuring through multimeter that there is no power supply in the wire, in which we will do testing. Voltage coming around 0 volt means there is no power supply. Now we can measure insulation resistance through mega. First we will check between phase wire and earth. We have connected red probe of mega with phase wire and mega black probe with earthing. Now we are selecting 250 volt DC and pressing test button. Value coming around 2.15 giga ohm. Showing value is good and circuit is fault free. Now we will check insulation resistance between neutral wire and earth. We have connected red probe of mega with neutral wire and mega, black probe with earthing. Now we are selecting 250 volt DC and pressing test button. Value coming around 2.15 giga ohm, showing value is good and circuit is fault free. Now technician wearing safety belt will reach at fixture with the help of ladder. Now technician checking proper tightness of fixture, ensuring there is no dust inside or on the glass. Physically, technician checking damages in fixture if any. Following issue may arise due to poor monitoring. Inadequate or poor reporting mechanism may lead to delay in repairing of the faulty lights, which may cause discomfort to human being. Non-uniform light intensity levels due to several reasons mentioned above, and higher intensity levels during off-peak traffic hours, leading to energy wastage. No control and/or mechanism to check power theft from the lines, meant for street lighting supply, causing revenue loss to both municipalities and the utility. Power quality control of street light. There is absence of any control systems on the input power supply quality, especially voltage conditions. The voltage levels at light terminals vary in wide bandwidth, leading to high power consumption. High voltage levels in the range between 250 to 280 volt are not uncommon in the system. This not only increases the energy consumption, but also leads to premature lamp failures, and hence higher O&M, operational and maintenance cost. Now we will check the voltage going to fixture. Before that we are fixing street light wire. Only after that we will switch on power supply for street light. For street light operation we need around 230 volt AC. Now through multimeter, technician checking voltage, which is as per requirement. Now street light ready for switch on. Now we will switch on MCB. Now you can see street light start glowing.